Hello and welcome to Raspberry Pi. Today we are here talking about microcontrollers and specifically the RP2350. My name is Paul Sherry. I'm in the business development team, and joining me is my colleague Chris. Hey Chris, can you introduce yourself?
Sure. My name's Chris Boross. I'm in the commercial team at Raspberry Pi, work with Paul. I'm based in California and handle microcontrollers for US customers.
Okay. Thanks, Chris. So today we want to talk about microcontrollers. Raspberry Pi is more familiar with making single board computers and well known for that. So what prompted Raspberry Pi to design and start selling microcontrollers?
Ooh, quick history lesson. So way back when we wanted to build, we were looking for a microcontroller to build a Pico style product. We couldn't really find one that was an existing one that was on the market that was going to be able to allow us to build a Pico style product at a great price point with the right features, which sort of led us down a path of designing our own microcontroller for use in our own products. And it was handy because we had a talented chip team that were able to basically build a 2040 for us. And we built it for use in our own products, in our own Pico products, but we also built it with a view to selling it to other companies who wanted to use it in their boards and their products.
Okay, interesting. So 2040 has been in the market for a while. So what would be the biggest piece of feedback from the community and the customer base that adopted 2040 that then shaped the architecture of 2350?
Yeah. So when we launched 2040 back in 2021, it was a fantastic launch and it gained a lot of popularity, and we sold many, many millions of chips. And we did get a lot of feedback from the field. And we kind of always knew that 2040 was lacking a few features that would make it suitable for business customers. So we kicked off the 2350 program to basically address those basically shortcomings in 2040. The main ones were things like the lack of security, so the lack of secure boot and encrypted code storage. Customers were asking for more CPU performance and more memory, and also more GPIOs. So we addressed all of those in 2350.
Okay, interesting. So 2350 is in the market now, it's in full production. Can you tell us a little bit about some of the applications it's used on and maybe some of the customers?
Yeah, so I guess the first tranche of customers were existing 2040 customers that wanted to migrate to 2350. As we announced it, we did an early access program around 2350, which went really well. Migrating from 2040 to 2350 was made really straightforward because they both share a common SDK. And once you laid out a new board with 2350, you could get all of your software working from 2040 to 2350, which is a simple recompile. So the software compatibility made that transition really straightforward. But since then, we've had a net new batch of a number of net new customers, anywhere from tier ones to hobbyists and board manufacturers doing things for products targeting, education and tinkerers, all the way from and a bunch of commercial customers, industrial customers, building things like robotics applications, got SCADA and some drones. Unfortunately, those are products that are still in development, haven't been released yet, so we can't actually talk about who they are. But I think throughout this year, we'll start seeing some products from some big names hitting the market with 2350.
Excellent. You mentioned earlier that there's new features in the 2350 that weren't in the 2040. So what would you say are the killer features of the 2350?
The main one is the robust security features that we've added to the chip that allow customers to enable secure boot, encrypted code storage. We support ARM Trust Zone on both the ARM Cortex M33 cores. We have on-chip OTP for key storage, a really clever boot ROM that's in the chip, and a number of other security features actually that I'll talk a little bit about more in later on in this video. The next big feature is basically fantastic price and performance. So we've 2350 is only 10 cents more, but we've literally doubled the CPU and memory compute that's in the chip for only that 10-cent adder. So really a small price adder for double the performance. So we've gone from Cortex M0s to Cortex M33s with hardware floating point. We've doubled the amount of on-chip SRAM to 520 kilobytes. And that's basically only adding 10 cents to the chip price. So you can buy a 2350 in a reel of, basically the 13-inch reels, it retails for 80 cents. So really fantastic. We think a disruptive price point in the market based on our competitors. So we also have PIO, which is a unique feature to the RP series of chips from Raspberry Pi. It is our fully programmable CPU offloading bit bashing engine that allows you to basically provide software-defined peripherals in the chip. It's basically a programmable state machine based processor core that can go off and do high speed timing critical bit bashing of any of the 48 GPIOs. So you can do software defined peripherals like things like we can bit bash high def DVI video, which is akin to HDMI. We can even do things like 10100 Ethernet through RMII. All under software control, and there's 3 of those cores in each of the 2350 chips. So you can have 3 different peripherals running in parallel with pretty much 0 ARM CPU load.
So you're not using the AM33s essentially when you're running the PIO blocks?
That's correct. They run independently, and they talk back and forth via DMA and FIFOs. So the ARM cores can be off doing other things while the peripherals are being implemented. It allows a lot of flexibility, and we actually have a large community base of people who've written cool things for PIO in the open source community as well. We've been adding to that, but it's sort of taken off a bit of a life of its own, and even people implementing their own PIO simulators, so you don't even have to develop on real hardware.
Okay, excellent. You talked about the ARM trust zone and the security features, and security is becoming very, very important for consumer electronics products. Secure boot people are putting into consumer products, etc. So can you tell us a little bit more about the 2350 security features that customers should know about?
Yeah, so the security features are there to enable sort of 3 sort of distinct use cases of our customers using the chip in a secure product. The main thing is a secure authenticated boot. So customers can, with a high degree of certainty, know that the software that's running in the chip is the software that they want to be running in the chip. So they can sign that software and store the hashes of the signed software into the OTP, and the boot ROM will only run software that matches the hashes that are stored in on-chip OTP, and that we also have a mechanism for AB booting as well. So that's signed boot and authenticated boot. We have the ability to store encrypted code in Flash so that people can't come along and do a Flash readout attack, and it makes it very, very tricky for people to reverse engineer the software that's stored in external Flash. And we have a reference implementation of how to do that easily using Pico tool. And then the last thing, which uses ARM Trust Zone throughout the chip, we fully implement ARM Trust Zone across the chip, and that's to be able to isolate secure and insecure software that's running in parallel on both the ARM cores. So you can restrict memory accesses, memory and peripheral accesses, and you can sort of sandbox unsecure software in the system. Most of this is enabled using the secure boot ROM that's in the chip. And we have tools to be able to, we have a very useful Pico tool that runs over USB from a host CPU or your programming station to be able to allow you to securely program the OTP and write the flash that's attached to the chip. We have a redundancy coprocessor that's a custom redundancy coprocessor that we built into the chip, which adds stack canaries to the on-chip boot ROM that allows the boot ROM to operate in a manner that makes it quite tricky to implement glitch attacks while the boot ROM is running. And that's actually we found and fixed some issues during the first hacking challenge to do with that. We have on-chip OTP, which is anti-fuse OTP, and that's there for storage of keys. We can even store software. In fact, you can even boot the chip from software stored in the OTP. But the main reason the OTP is there is for key storage and storage of hashes, and gives our customers a secure place to store code in. Although there have been there's one identified attack against that OTP, or it's not just us, it's all users of that same OTP cell. And there's in the data sheet we have mitigation strategies for how to mitigate that attack. We also support, as I mentioned before, ARM standards trust zone for isolation of secure and insecure software running in the chip. And then I guess last thing to mention about security is how we've implemented it so through radical transparency. So most of our competitors, the vast majority of our competitors, hide all of their security features of their chip behind NDAs and customer vetting, and they will only let a certain type of customer get access to the register definitions and the implementation guides of the security that's in the chip, which means that a lot of their customers can't actually implement security in their products because they don't meet the bar for the customers that get allowed that stuff. We're very different. We make all of our security architecture completely opaque. It's all detailed in the data sheets. We've even open sourced our boot ROM, which is very unusual and it allows people to go in and review it and give us feedback and find issues with it. So that's we've even run a couple of hacking challenges. The first hacking challenge was very successful, and there were multiple winners. And we were made aware of a bunch of issues with the chip that we actually fixed with the A4 SKU of the chip. And we're actually running a second hacking challenge, which is currently running at the moment, and that's to do with side channel analysis. And thus far, we haven't had any winning submissions.
That's excellent. So thanks for that overview. So 2350 sounds like a significant upgrade over the previous generation 2040. So ideal for industrial and embedded customers with a very great low cost price point as well. So if a developer wants to get started, what's the best place to go?
Good question. So we wanted to make the chip and the SDK extremely easy to get started with. So Pico is a Pico 2. Pico 2 2W are very very inexpensive hardware devices to get going with. They're also very easy to develop for. We have a really nice C and C++ SDK. We support MicroPython, Rust, different operating systems, FreeRTOS, Zephyr. So it's really, and a bunch of great documentation. Actually, I think our documentation is, we take a lot of pride in our documentation, put a lot of work and thought into documenting both the hardware and software really well. So we have getting started guides and a data sheet that we think set the bar really, really high for documentation in microcontrollers. So yes, I think it's really straightforward for customers to pick up a Pico 2 or a Pico 2W if they want wireless LAN and Bluetooth and get going. It's we also have, I should mention, we have a really nice VS Code plugin as well that supports all of our SDK and MicroPython, including Zephyr OS, that's free.
Great. So the customers can go to raspberrypi.com and just download the documentation and the
Absolutely.
SDK.
Yeah, and it's all on GitHub and it's all open source.
Yeah. Okay, excellent. So one important factor for a lot of customers is longevity. So how long is your product going to be around? Are you going to be able to continue to buy it, get it supported, etc.? So what can you tell us about 2040 and specifically 2350?
So 2040 is going to be available at least until January 2041, and 2350 is going to be available at least 2045. They may well be on sale beyond those dates, but those are the dates we guarantee. We have a lifetime commitment guarantee for all of our commercial products. That's pretty great. Also, I should mention that these parts are available through our reseller network and our distribution network. So you don't have to buy them from Raspberry Pi. You can buy them from disties and our approved resellers all over the world at short notice, with local shipping. The parts have been in channel now for A4 has been in market since last July.
Okay, excellent. Eben mentioned last year that 2025 was the first year that Raspberry Pi sold more units of microcontrollers than actual single board computers. So it's obviously there's a move towards becoming more a silicon company in addition to being a compute company. So what about future developments? Can you tell us a little bit about what the plan is going forward?
Yeah, sure. Yeah. So we recently came out with two new SKUs, packaging SKUs of 2350. We came out with a pair So there's a pair of 2350s. There's the AMP package, which are different package size, different GPIO count, but fully software compatible. Last year, we came out with 2 new SKUs that are fully software compatible with the standard 2350s, and they contain 2 megabytes of stacked QSPI flash. So if you want to build a smaller product with a smaller footprint, or if you want to just simplify your design, you can buy a version of 2350, which is called 2354, A or B, with a stacked flash. It makes your design a little bit easier, and it saves you having to source flash from somewhere else. It's just sold with flash in package, and it still allows you to, both of those packages still allow you to use external flash on the second chip select, or PSRAM on the second chip select if you'd like.
Okay, excellent. So that's been a really great overview, Chris. So one final question for you. You mentioned the dual Cortex M33, but 2350 also has dual RISC-V cores. So what's the rationale behind that, and why did we put that into the chip?
Yeah, so 2350 is quite unusual. It's a dual core, dual architecture microcontroller. We added a pair of Hazard 3 RISC-V cores that clock at 150 megahertz. They were developed by one of our ASIC engineers called Luke Wren. It's a fantastic little core that he designed himself that we put them in there really as a bit of a love letter to CPU enthusiasts, and also to give the community access to new RISC-V cores basically at zero cost. You can choose which cores your chip uses through software. You can use OTP bits to enable or disable either core. The default cores are the ARM cores, and in the chip, if you enable secure boot, then the RISC cores are disabled because it would be an attack vector to have both cores present on a secure chip. And also, trust zone is not supported on the RISC cores. So if you have a secure chip, then you have to use the ARM cores. But for people who want to experiment with RISC-V, this is a great platform for them to sort of pick and choose. They can have one design that runs RISC code or ARM core or ARM cores just at the flick of a switch, and it's fully under software control.
Excellent. Okay, well, that's a really excellent overview of the 2350, Chris. Thank you. If anyone is interested in further information, they go to raspberrypi.com, download all the documentation and the SDK, and if you need Picos or 2350s, go to the reseller network globally for your local source.
Yeah, and if you'd like to get in touch with the Paul or I through in the commercial team, there's a new form on the 2350 product page that customers can go to, fill that in, and it'll shoot a message to you and I.
Thanks, Chris.
Thank you very much. It's been fun chatting.